right, today we're finishing our rational unit, and we're actually going to define rational numbers today. On your learning target, you can identify and order rational and irrational is a keyword number. So I made a little web. Every number in this whole entire world is either rational or irrational. It's one or the other. So rational numbers are the most common numbers. Rational numbers is anything you can write as a fraction. If you can write it as a fraction, it's rational. So integers are rational numbers. Integers. That means -2, -1, 0, 1, 2. All the way to negative infinity and positive infinity. Those are rational. You can put a 1 on the bottom and make it a fraction. You can put decimals. Anything with a decimal you can turn to a fraction. You can turn 3.5 into 3 1/2. And you can turn 0.2 repeat into 2/9. So any repeating decimal or a decimal that ends is a rational number. You can turn it into a fraction. Clearly then a fraction is rational because it's already a fraction. And any perfect square root. Any perfect square root is a rational number. What I find typical 8th graders be able to do the best is know what irrational is, because there's so many possibilities for rational numbers. If you can define irrational numbers, then you're set. So irrational, let's make maybe a little mini width or a mini heading down here. Irrational is two things. I have two things. Here's how awesome it is. Irrational is pi. Pi is irrational. It's a decimal that never repeats itself and never ends. I can't turn that into a fraction. The only thing I can turn into a fraction is a decimal that ends and a repeating decimal. And the other irrational number is the square root of not a perfect square. It's much easier to identify something's irrational than rational. So when I'm given a set of numbers, I look for irrational first, because I know I'm looking for not a perfect square root or pi. It's so easy. And if it's not one of those, it's rational. Just kidding. There's one other weird one. If you do like 2.12, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. Although that's a pattern, it's not a repeating decimal. I can't turn this into a fraction. I can't assign a variable to be the pattern. Okay? Mike?
Well, that just means it would keep on going and you put an end to it, which would make it rational.
No, it keeps on going to infinity. You're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way.
Well, you stopped there, which made it rational.
Oh, yeah, true. I got to put the dots. Good call. I got to put the dots to say this keeps going. All right. Let's try to identify. Remember, irrational. If it's not a perfect square inside the square root. So we're going to classify the following. The square root of 100. Do you think that's rational or irrational? Rational. Yep, that's rational because it's a perfect square root. Feel free to use your chart to help you. -5/13, rational or irrational? Well, rational is anything you can write as a fraction. Hey, it already is a fraction, so it's rational. Or 0.3 and then repeating the 6. Rational or irrational? It's a pattern, right? The 6 keeps repeating. You can write a pattern as a fraction. Three-fourths, rational or irrational? Rational, because it's a fraction. Negative 1.234, and that keeps going. Rational, because it's a pattern that I can assign a variable to. So this would be rational. The square root of 37. Irrational, because 37 isn't a perfect square root. Square root of 12 over 5. Irrational. Now here's tricky. You're like, well, it's a fraction, right? Fractions are rational, but a fraction has to be a ratio of 2 integers. This is not an integer. This is an irrational number, which means the whole thing will be irrational. Okay. Good. That's my learning target of today. Just can you define rational and irrational?